Okay, so when will termination occur? What is termination? Termination means stop the reaction. You do not want the free radical reaction to go on and on. It cannot go on and on. All reactions must come to an end. When will the reaction stop? Basically, when two radicals combine. They pair up. Okay? So what happens is that when two radicals combine, you destroy the radical. Okay, what do you mean by this? Okay, so when two radicals combine together, for example, Cl dot and Cl dot here. Okay, when two radicals combine, okay, you may want to represent it this way. That means the two chlorine radicals with the unpaired electrons, they pair up to form a bond. So imagine the Cl dot and another Cl dot, they come together, okay, and then they form a Cl-Cl bond. Okay, they form a Cl-Cl bond. Okay, is it necessary to show the arrow? Not necessary in the termination step. You only have to show the half arrow in the initiation step when the Cl-Cl bond breaks. So that means to say in this mechanism, we only expect you to write the arrow here. Please show the arrow for the initiation step only. Okay? For termination, we are just trying to get you to see that when two radicals come together, okay, you pair up the electrons, and then once you pair out the electrons, you form a normal bond, no more radicals already. Okay, this can happen for any two radicals that meet. So if let's say you have this ethyl radical combining with the Cl radical, the two unpair, the carbon dot and the Cl dot, the two unpaired electrons will pair up and then you will form a bond, the CCl bond here. Okay, of course you don't have to show this. In fact, the arrows are not necessary in the termination. It's not necessary to show arrows in the termination step. And what happens if two ethyl radicals were to combine? Then you can end up having a CC bond forming. This carbon dot will pair up with the other carbon dot, okay, and then you will form this. Carbon-carbon bond. This is how from 2 carbon ethane we can end up with 4 carbon butane. Okay, in the termination step. In the free radical substitution of ethane, we can end up with a byproduct butane. Okay, and to also mention, we want to also mention here that if chlorine is indeed in excess, we can actually substitute not just one hydrogen with chlorine, okay, because we actually want to substitute only one hydrogen with chlorine, right? We only want monochlorination, or we can end up with dichlorination. 2 hydrogen get substituted with chlorine. We can end up with trichlorination. 3 hydrogen atoms of ethane get substituted with chlorine, or even tetrachlorination. So there's a wide mixture of products. Okay, so yes, so this is actually what happens. We get a mixture of products. So how to prevent this from happening? Okay, to prevent this from happening, usually we use limited chlorine. So if let's say I want to actually just form exclusively the okay, if I exclusively just want to form monochlorinated ethane, then I should use limited chlorine. Okay, limited chlorine. With limited chlorine, then I have very little chlorine Cl2, then I will limit the chlorination process. Okay, then I'll only get monochlorination.